Today we're going to talk about more on functions and their graphs. This will be a two-part video. This video is part one. We're going to talk about how to identify intervals on which a function increases, decreases, or is constant. Use graphs to locate relative maxima and minima. Test for symmetry. Identify even or odd functions and recognize their symmetries. Understand and use piecewise functions, and find and simplify a function's difference quotient. So first let's talk about increasing, decreasing, and constant function. A function is increasing if the y values continuously increase as the x values increase. We're going to find the region where the graph goes up from left to right, and then we're going to write it in interval notation. A function is decreasing if the y values continuously decrease as the x values increase. We're going to find the region where the graph goes down from left to right, and we're going to write in interval notation. A function is constant if the y does not change as the x values increase. We're going to find the region where the graph is a horizontal line, and we're going to write that in interval notation. So in this first graph, as you can see, it goes down, curves up, goes back down, and goes back up. So we're going to write the intervals in which the function is increasing, decreasing, or is constant. So as you can see, it's coming out from negative infinity, and as it goes up, it's going up to positive infinity. I'm going to mark these points on this graph so we can figure out where it increases and decreases. And when we write it, we're going to write it in terms of the x values. Okay, so let's look at increasing. So this graph goes from the bottom, so it's going up to negative infinity, and then it hits this point, negative 1, 1. We're only going to write the x value. So this is increasing from negative infinity up to negative 1. And it looks like it also increases again here from this point 1, negative 1 to infinity. But I'm only going to write the x value. So it's going to start from 1 all the way out into infinity. Now let's talk about decreasing. From the point negative 1, 1 down to 1, negative 1 is a decrease, because as you can see, our graph goes down. We're going to write it in terms of the x values. So it decreases from negative 1, 1. This graph is never constant. As you can see, there is no horizontal line. This next graph is this red graph. From here, I'm going to put it in yellow. From here and from here is a constant, because that's a horizontal line. But let's figure out where it's increasing, decreasing, and or constant. So at this point here, this is the point negative 4, 2, and this point here is 4, 7. So let's look at the increase. It's increasing from negative 4, 2 all the way up to 4, 7. So I'm going to write it in terms of x. So it's increasing from negative 4 to 4. There is no decrease. This graph does not dip down anywhere. So now let's look at the constant. So if you go out here, this is negative infinity, and if you go out here, it's positive infinity. So it's going to be constant from negative infinity all the way up to negative 4, and then it's constant again. It's going to start at 4 up here all the way out to positive infinity. All right, let's look at another problem. So here we're going to have an increase, a decrease, and a constant. So I'm going to go ahead and mark these points. This point here is negative 5, 6. This point here is 3, 6. So if you look at the increase, we're going to see, where does the graph go? Where does it go up? We have this point down here as well, negative 1, 1. So it increases from negative 1, 1 all the way up to 3, 6. We're going to write it in terms of the x value. So it's negative 1, 3. Let's see where the graph is decreasing. So it looks like it goes down from negative 5, 6 to negative 1, 1. We're going to write that in terms of x values. And then there's another decrease. It looks like it's going from 3 all the way out into infinity. So it's going to go from 3 to infinity. As far as the constant value, where we have a horizontal line, if you look out here, this is negative infinity. It's coming from negative infinity to negative 5, and that's the constant because we have a horizontal graph, a horizontal line. So next we're going to talk about how to use graphs to locate relative maxima and minima. A relative maximum point is a point where the graph changes directions from increasing to decreasing, and that's making that point a peak in the graph. A relative minimum point is a point where the graph changes direction from decreasing to increase, making that point a bottom in the graph. A relative maximum minimum deals with the location on the x-axis. The relative maximum minimum deals with the height on the y-axis. So if you look at this next graph, and let me go back, I wanted to show you. So if you have a graph and it has a peak, this is your xy. That point is your peak. So we're going to call this xy, we're going to call the x the maximum. We're going to call the y the maxima. When you have a bottom peak, this is your xy, we're going to call this x your minimum because this is a low value. And we call this y your minima. Okay, so let's look at this example here. And as you can see, we have a peak and we also have a bottom. This peak here is the point 112. And then you have a bottom here, which is the point 4, negative 15. So let's look at the relative maximum. Remember, we're only going to look at the x value at the peak. So this would be x is equal to 1. The relative maxima is the y value of that. So y is 12. Sorry for my scribble scrabble. Let me see if I can erase some of this so you can read it. There we go. All right, so now let's look at our minimum point. That's the bottom. We're going to look at the relative minimum. And that's going to be x is equal to 4. And then your relative minima is your y value at that point, and that's y is equal to negative 15. So now we have another graph. I'm not sure if you can see these points, but this is the point negative 2, 2. This bottom point here looks like it's 0, 2, or 0, negative 2. Then we have a peak here. That looks like it's the point negative 1, 2. Negative 1, 2. All right, so let's look at the relative maximum. So that means we're looking at a peak. Relative maximum. X is equal to point negative 2. And we also have 0. So we're looking at these 2 points here. Then our relative minima will be the corresponding y values. We'll have a 2. Sorry, a negative 2. This should be a negative 2 here. And then we have another negative 2 there. So we have 2 relative minimums and relative maximas. Next, we're going to talk about the test for symmetry. The graph of an equation is symmetric with respect to the x-axis if the replacement of y with negative y results in an equivalent equation. The graph of an equation is symmetric with respect to the y-axis if the replacement of x with negative x results in an equivalent equation. And the graph of an equation is symmetric with respect to the origin if the replacement of both x with negative x and y with negative y results in an equivalent equation. And I gave you this calculator because you can actually graph, and I'll show you the graphs in a few minutes, but you can use the calculator to see whether or not these graphs are symmetric about the x, the y, or the origin, or if there's no symmetry at all. So let's look at this first one. We're going to determine whether or not it's symmetric with respect to the y, the x, the origin, more than one of these, or none of these. So the first thing we're going to calculate is symmetry about the x-axis. And to calculate that, we're going to set y equal to negative y. So I'm going to have negative y equal to 5x squared plus 4. Then I'm going to go ahead and get y by itself. I'm going to divide everything by negative 1, and I get negative 5x squared minus 4. This is not equivalent to my original equation of y is equal to 5x squared plus 4. Okay, so it's not equal to this. So since it's not equal to this is not symmetric about the x-axis. Okay, so now let's do another one. We're going to see whether or not this is symmetric about the y-axis. And to do that, we're going to set x equal to negative x. So whenever I see x in the original problem, I'm going to set it to negative x, and then I'm going to go ahead and simplify it. So I know that negative x squared is just negative x times negative x. This gives me 5x squared plus 4. As you can see, this is equivalent to my original problem of y equal to 5x squared plus 4. So it's equal to this. So since it's equal, we can say that this is symmetric about the y-axis. Now we're going to check for symmetry about the origin. And to do that, we're going to set x equal to negative x and y equal to negative y. So I'm going to have negative y is equal to 5 times negative x squared plus 4. I get negative y. We already know that negative x squared is just positive x squared. And then when I divide everything by negative 1, I get y is equal to negative 5x squared minus 4. This is not equivalent to our original equation. So there is no symmetry about the origin. Okay? So the only thing that is symmetric about is the y-axis. So I put the graph up here of this function, of this equation, and as you can see, it's a U-shaped graph. So when we say that it's symmetric about the y-axis, that means if you fold this graph along the y-line, the y-axis here, the red lines would meet up. So you just fold it in half and the graph meets up. So that's what it means when we say it's symmetric about the y-axis. So when folded along the y-axis, the red graph, in this case, meets up. Okay. So now let's do another problem. We got x is equal to 3y to the fourth minus 2. Let's check to see if it's symmetric about the x-axis. And to do that, once again, we're going to set y equal to negative y. So whenever I see a y in this problem, I'm going to change it to negative y. Negative y to the fourth is just positive y to the fourth. And as you can see, when we simplify it, it is equivalent to our original equation. We get the same as we started off with. So that means that it is symmetric about the x-axis. So now let's talk about symmetry around the y-axis. And to do that, we're going to set x equal to negative x. So whenever I see an x, I'm going to change it to negative x and then simplify. So I'm going to divide everything by negative 1. I get x is equal to negative 3y to the fourth plus 2. This is not equivalent to my original problem. Okay, so there is no symmetry about the y-axis. Okay, now we're going to do symmetry about the origin. And to do that, we're going to set x equal to negative x and y equal to negative y. So I'm going to have negative x is equal to 3 negative y to the fourth minus 2. I already know that negative y to the fourth is a positive y to the fourth. When I divide everything by negative 1, I get x is equal to negative 3y to the fourth plus 2. This is not equivalent to my original problem. So there's no symmetry about the origin. Alright, so I did a graph of this, and this is what the graph looks like. We stated that this graph was symmetric about the x-axis. So this is the x-axis here. If you fold your graph in half along the x-axis, the graph will meet up. So the reason why I gave you that calculator is so that you can go ahead and graph these so you can see visually if the graph folds, if the graph will meet up about the y-axis, or if you fold it and it meets up about the x-axis. So you really don't have to go through all these calculations when you're doing your homework. However, on the test, you're going to have to know the steps. But for doing the homework, you can just graph it and look at it visually. Okay, let's do another one. This time we have y is equal to x cubed minus 2x. Let's see if it's symmetric about the x-axis. So to do this, sorry, gotta erase this. To do this, once again, we're going to set y equal to negative y. So I have negative y is equal to x cubed minus 2x. To get y by itself, I'll divide everything by negative 1. I get y is equal to negative x cubed plus 2x. As you can see, this is not equivalent to our original problem. So there's no symmetry about the x-axis. Now let's check for symmetry about the y-axis. We're going to set x equal to negative x. So I get y is equal to, oops, sorry. Oh no, what happened? I'm trying to erase this and I don't know what I did. Okay, let's do this. Okay, I'll just delete it. Okay, we'll just do that. Alright, so we're going to set x equal to negative x. So we'll have y is equal to negative x cubed minus 2 times negative x. I get negative x cubed is just negative x cubed plus 2x. As you can see, this is not equivalent to my original problem. So there's no symmetry about the y-axis. So now we're going to talk about symmetry about the origin. And once again, to do that, we're going to set x equal to negative x and y equal to negative y. So we end up with negative y is equal to negative x cubed minus 2 times negative x. We know that negative x cubed is just negative x cubed, and then this is plus 2x. Divide everything by negative 1. I get y is equal to x cubed minus 2x. This is equivalent to our original problem. So that means we have symmetry about the origin. So what does that mean? When we graph this, we get this graph here. Okay? So when it's symmetric about the origin, if you flip this graph upside down, you're going to get the same graph. So the graph looks the same if you flip it upside down. Okay, so I'll put that on here. Graph looks the same. Upside down or right side up. It's the same graph. So that's what we mean by symmetry about the origin. You just flip it around, it's the same graph. Okay. Let's look at another one. We have x squared plus y squared is equal to 16. Let's check for symmetry about the x-axis. We're going to set y equal to negative y. I get x squared plus negative y squared equal to 16. We know that y squared, negative y squared, is the same as a positive y squared. So as you can see, this is equivalent to my original problem. So that means we have symmetry about the x-axis. Now let's talk about symmetry about the y-axis. Like I said, we're going to set x equal to negative x. Whenever I see an x, I'm going to plug in negative x. And we know negative x squared is a positive x squared. And when I simplify it, I get the same equation as the original equation. So that means we have symmetry about the y-axis. Now we're going to talk about symmetry about the origin. And we're going to set x equal to negative x and y equal to negative y. So I'll have negative x squared plus negative y squared is equal to 16. Negative x squared is just positive x squared, and the same goes for negative y squared. We get positive y squared. As you can see, this is equivalent to my original problem. So this is symmetric about the origin. So when we graph this, you'll see that we come out with a circle. And as you can see, it's symmetric about the x, the y, and the origin. If you fold this graph in half along the y-axis, the graph meets up. If you fold it in half along the x-axis, the graph will meet up. And if you turn this graph upside down, you'll get the same graph. So it's symmetric about all three. Okay, this is going to be the last one for this part of the video. We have y is equal to 7x plus 10. Let's see if it's symmetric about the x-axis. I'm going to set y equal to negative y. I'm going to divide everything by negative 1. I get y is equal to negative 7x minus 10. As you can see, this is not equivalent to my original problem. So it's not symmetric about the x-axis. Now let's check for symmetry about the y-axis. I'm going to set x equal to negative x. So I get y is equal to 7 times negative x plus 10, which is y is equal to negative 7x plus 10. As you can see, this is not equivalent to my original problem. So this is not symmetric about the y-axis. And now we're going to see whether or not there's some symmetry, if there's symmetry about the origin. We get negative y is equal to negative 7x plus 10. If we divide everything by negative 1, I end up with y is equal to 7x minus 10. As you can see, this is not equivalent to my original problem. So it's not symmetric about the origin. So in this case, it's no symmetry whatsoever. And when you look at this graph, it's a line. So if you fold it about the y-axis, if you fold it along the y-axis, the graph does not meet up. If you fold it about the x-axis, the graph does not meet up. And if you turn it upside down, you do not get the same graph. So there's no symmetry at all. So this is part 1 of the video.